In a previous video, we took a look at stateless auto configuration, and we've got a couple machines on the network right now. We've got this XP box on this network segment, and this device, which is a Unix box, over here on this network segment. And I've also put in routing between R1, R2, and R3. I'll do a separate video on routing in the next segment. But for now, I want to share with you one other really important aspect of getting IPv6 up and running, and that is not only do these devices, these hosts need IPv6 addresses, but they also are going to need DNS, so they can get to servers based on host names. In this quick tutorial, I'm going to walk you through how we can train R1 or R3 to support their clients to allow them to do their automatic stateless auto config, but we're going to add in something called stateless DHCP. The whole concept is really simple. We're going to advertise when this client comes online and they do their router discovery and we send a router advertisement. We're going to train this router to send inside of its router advertisement a little option flag. Now this option flag says, hey buddy, there's other options available. And then the client can say, oh wow, even though I'm a stateless auto configuring IPv6 device, I think I'll go ahead and find out what options the server has for me. In this case, we'll have R1 act as a DHCP server. So the router advertisement has the information that there's more options available. The client then makes a DHCP request to say, hey, give me those additional options you mentioned. And then there's a response that goes back that can hand the clients a DNS server. So it's like setting up DHCP. It is actually setting up DHCP, but not assigning hosts their addresses, instead just handing out clients DNS information when they ask for it. I've already got R1 configured. Let me take you over to R3 and we'll configure R3 for DHCP, starting off where we left off in our last lab, which was IPv6 addresses are already configured. Stateless auto configuration is set up for the hosts. We're simply going to add the DNS option. So here on R3, we'll make sure we're on the right console. Let's go ahead and start our configuration. So in configuration mode, a couple of really simple, basic things. We're going to create a DHCP pool. Even though we're not going to be handing out hosts their IP addresses, you have to have a pool to put in the DNS information that you will be handing out. So we're going to create a pool first here in R3, and then we're going to specify, let's just call it my pool. You can name it whatever you'd like. You can call it your pool if you'd like. And then we're going to specify inside of that pool the DNS server that that client should be able to use. So hopefully you're going to put in an IPv6 address of a real, reachable DNS server. In this case, I'm just going to make sure it's really visible, and we'll plug in the DNS server of 2001 DB8 21 5555::5. So whenever you see that IP address, you'll know, oh, that's the DNS server information. Next, we have to do some little magic here on this interface, FA0/0. We need to tell this interface that it should reference that pool, that DHCP pool that has the DNS server information in it. So in interface configuration mode, we simply say IPv6 DHCP server my pool. And that tells this interface what information it should pull from when it's advertising its DHCP information if clients request it. So that's pretty straightforward. Second thing we need to do is we need to tell the router's interface, hey, listen, when you send your router's advertisements out, go ahead and include the O flag, meaning there's other options available. Then the client, after it auto-configs, can make a DHCP request, ask for the options, and then you can give it to him when he's ready. So that's it. So what we do in interface configuration mode is basically two things. This command here, and then we go ahead and specify the IPv6 neighbor discovery other config flag. And that sets that flag to O, meaning, hey, there's other options available. And that's it. Now what we can do is we can simply debug IPv6 neighbor discovery, bring up our little host, and let's bring up this guy right here. I've got this virtual box. He's on this network. I'm going to bring him up full screen so we can see a little better. And I'm going to disable his interface just for a moment. It's not very nice, but he'll get over it. So if I go to the interface for this guy and I say, disconnect the cable, okay. He's going to say, oh, the cable's missing. That's a huge problem if you want to communicate. I know, but we'll bring him back in just a moment. Also, what I'm going to do right now, I'm also going to capture the network traffic off of this segment. So I'm going to go back to network adapters, logically plug back the cable in, click OK, and you'll notice we're going to see a router solicitation come in, and then a router advertisement based on the router responding to that. Okay, so let me go ahead and bring this down just a little bit. In fact, I can make it a little bit smaller. So here's a router solicitation right there coming from that host. And in response to that, we sent a router advertisement. And I have captured that. Let's go take a look at the details of what's been captured. So here's our capture of what just took place. And we'll bring the client up as well just to make sure he did get an IP address, that it works. And we'll bring him up full screen just for a moment. And let's go into networking tools here. So that'll work. That's a good enough networking tool. ifconfig will show us the IPv6 address that he got, if any. So this is Ethernet 1. Here's his IP address that he got. So it's on the 2001 DB821.333 subnet, and then he used the EUI64 modified format for its host ID. Fantastic. We also have learned a DNS server. Now the DNS server is not showing up here. There's probably another way of looking at that. But let's go take a look at what happened on the wire and verify the back and forth. We've already taken a look at the duplicate address detection in a previous video. So here, when we have this guy sending out requests from his unspecified address, he's trying to do duplicate address detection to make sure he's not in conflict. Then once he has an IP address, he does a router solicitation, and that router solicitation is responded to by R3, and this happens to be the link local address for R3. And in that response, here's the router advertisement, and we have this flag other. So if this right here flag was set, that's the managed flag. That means, hey, you're going to get an IPv6 address, a global address from me. No, don't go ahead and do your auto config. But by default, that's off, and we set the other flag with that configuration that we added. So by telling the interface that we have other options to offer, that changes our router advertisements, which then goes to the client. So the client at this point in the game knows exactly what it did previously. It says, well, basically, you're telling me what network this is. We'll take a look at that. So here's the network down at the very bottom. Let me bring that back up a little bit so you can see it. So here's the network in question. I can do my auto configure, and you're telling me that I've got other options that I can get from you. Great. So it does a whole, now there's some other services running on this Linux box, and this all happened, if you look at the timestamp, within just like 1 or 2 seconds. These are milliseconds on the right-hand side. So then we go down to DNS, or DHCP, and now we have a request. This is the client. It's just like 1 second later making a DHCP version 6 request saying, hey, I'd like the other information you mentioned in that router advertisement you gave me. And what would a very good DHCP server do, or router do running DHCP? It would reply. And here's the reply to it. So the biggest part of this DHCP version 6 reply is the IP address, rather, of the DNS server he should use. So this device, this Linux box, now has an IPv6 address that's auto-configured, and we used stateless DHCP, where we didn't hand out the IP address to the customer, but we did give it information on a DNS server, and that's what we're looking at right here. So if this all is working, let me minimize this a little bit, we should be able to ping from our two devices. And if DNS is working, if I had a real DNS server, we'd have full DNS capability across the board too. So this PC right here is a Windows XP box. It's on this subnet, and this Linux box is over on this subnet. They both auto-configured, they both got DNS information, and they both got a default gateway through their stateless auto-config. So we should be able to ping. So let's ping this address right here. Let's take the IP version 6 address and see if I can just copy that. It'd be a lot easier. And let's ping him. Let's go ahead and bring this up a little bit and bring this full screen. And let's go to a command prompt. All right, so let's do a ping. I think we can do ping or ping 6. It doesn't really matter. And then we'll paste in that IP address and take off that slash at the back. And if we can ping it, that's basically verifying that we can go all the way across the network. And sure enough, and there it is. We can even verify our path by doing a trace RT6, the version 6 version of trace route, and plug in that IPv6 address again. And that should give us a trace across the network. So the first hop is R1, and then it should go to R2, and the last hop should be R3, and then it should go to the final Linux box itself, which has that funky address. So that's the trace route for IPv6 across the network. So stateless auto config is a piece of cake. We did that previously. All we did in this one is we simply kicked it up a notch by adding stateless DHCP with the entire purpose of handing out a DNS server as part of the process. Hey guys, thanks for watching, and I'll catch you in the next video.